We already made the system palette generic. Now let's take it a step further by introducing a custom config trait. This mirrors the real Substrate SDK and is the secret to writing scalable, modular runtimes. Now, before we move on, a quick reset, because it's going to be complicated. So breathe in and breathe out. Again. And out. And focus. Why do we need this? Well, imagine we have at some point, our palette is gonna have so many generic arguments that it's gonna be hard to keep track. And always when you use it, you have to specify all of them. So what we're gonna do instead is say pub trait config. And here we can declare different kinds of traits like type account ID, which is gonna need to implement order. And maybe clone, right? Clone. Let's go with clone. Now type a block number, which is gonna have 0 plus 1 plus add assign plus copy, and so on, right? And then what we can do is come in here, and instead of this nasty palette over there, we can just say, hi, it's gonna implement, so we're gonna have one generic T, and this one generic T is going to implement our config trait. And that's it. Crisp, simple, and sweet. What else you might need to know is how do we now access the type account ID, for example. In here, we define account ID, let's say like that. And then we go like T, double colon, and now we can access the account ID, and that's it. So we always specify T and get into it and into our associated type. It's time for real talk. In one of my older Rust projects called Rust Scheduler, I didn't follow this pattern. I thought it's smart to make everything super generic everywhere. It looked flexible in the beginning, but quickly became a huge pain. The compiler started yelling at me with weird errors, things like cannot infer type parameter or some long trait bounds I couldn't even understand anymore. And once your project has like 5+ modules using all of those generics, total nightmare to debug. So yeah, using associated types like in this step really helps. It keeps things clean and you avoid a lot of unnecessary headaches. Let's get back to our code. Let's assume now we have the config trait, our palette, this palette here. We can delete the palette at the top. And we get now a few errors, but it doesn't matter. Now the concept is important. So we assume we have now this palette struct with this generic type T, which implements config, and this is here our config. Now, inside our runtime, our system palette will change a little bit. So instead, what we can see right here, we will have something that implements the system config trait. It will be some struct that implements system config. This might be not very readable, but you should get the concept. And now let's think, what would come closest to implement this system config trait? Well, what we could do is say, hey, runtime, maybe you would like to implement it. We do implement system config for our runtime. Now we get a few warnings like not all trait items implemented, missing account ID and block number. So we define these types. Block ID is, now we could say string, but we want to make it reusable. And we have this central station for all our types, so we can just always have one like a single source of truth, what kind of types are being reused everywhere. So instead we go into types and say account ID and now type block number, but let's change it to block number, and here as well, types block number. Nice. And now, because we implement the system config trait for the runtime, we can go in here and say, hey, runtime, you know what, system palette, your generic argument, which implements the system config trait, is yourself, basically. And this is now throwing an error, obviously, because we haven't fully implemented it, but I hope you get the picture. Let's wrap it up. I already kind of showed you the solution. Anyways, here's coming the problem statement. We define a new trait called config. This config is supposed to replace the 3 generic arguments we can see here for our systems palette. You will need to make some adjustments because this will be one generic argument T implementing our config. Won't be able to just access the block number. Instead, what you will need to do is go inside the generic argument, and this generic argument will have associated types which you can then access, and they will have, again, some methods associated to them. To have all these methods, which are going to be associated, we're going to use these trait boundaries here. So the next step will be get rid of these generic arguments. There will be only one implementing our config, but you will need to move these trait boundaries to our config up here. So this will specify them, right? You will need to make adjustments because of that to wherever we've been now accessing just our generics, we would need to access them through the or whatever your generic argument is going to be. After that, let's move to our tests. This is not going to work anymore. Here, specifying string u32, u32. Instead, what we want to do is come up with one struct like test config as described here. And this test config is gonna implement our config. And here we'll specify some type, account ID, whatever it is gonna be, right? And then you can come in here and say, okay, because this is not gonna work anymore to just implicitly derive it. So you won't be able to say, just create new, because it's not gonna be known. The compiler cannot derive what we mean here. What kind of a palette is it? So we will definitely need to go in here and say, okay, this is gonna be the generic argument is gonna be a test config, because this is implementing our system config. After we're done here, you've kind of made the greatest progress, because now we need to apply the same patterns for our runtime. Define the system config for our runtime, then specify the types. Remember to reuse our central station for our types. Then go in here. You will need to get rid of these generic arguments and replace this just with whatever implements our system config. In this case, it's going to be our runtime. So either you write here runtime or self, but I definitely recommend to write self. This is it. Go ahead, solve this step, and after you're done, come back, and in the next video, we're going to have a look at the solution.